Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math algebra problem, and here we have n over n plus 1 whole square plus n over n minus 1 whole square equals to 12, and we solve this problem for the values of n. So that the very first thing we are going to do is, here first we take the value of this base is a, and we denote this base by b, so that here we take a equals to n over n plus 1, and we take b equals to n over n minus 1. And when we put these two values in the above equation, then we get a square plus b square equals to 12. And now here first we complete the square of this equation, so that in order to complete the square of left hand side, we need the term plus 2 times of AB. So here we need this term, so that we add and subtract 2 times of AB here, and this whole equals to 12. And now here you see that the sum of when you combine all these terms, then it will be equals to a plus b whole square minus 2 times of AB equals to 12. And now we back substitute the values of a and b, and you see that this is the value of a and this is the value of b. So if we put these two values in the left hand side of this equation, and we get, here you have a plus b whole square, the value of a is n over n plus 1, and plus the value of b is n over n minus 1 whole square minus 2 times of a is n over n plus 1, and b is n over n minus 1, and this whole equals to 12. So now here we need little bit simplifications here, so that in the first factor we take the LCM of this term, and you know that the LCM of this term will be equals to n plus 1 times of n minus 1. And when we divide this n plus 1 by here, then n plus 1 is cancelled by n plus 1, and you get n times of n minus 1, and plus here you get n times of n plus 1 and its whole square, minus here we multiply these two terms, and we get 2 times of n square over, here we have n plus 1 times of n minus 1, and we use the square identity, which is a square minus b square equals to a minus b times of a plus b. So this expression will become n square minus 1 equals to 12. So that here we simplify this term, and we multiply this n on both of the terms and this n on both of the terms, and we get n square minus n plus n square plus n divided by n plus 1 times of n minus 1, and it is equals to n square minus 1 and its whole square minus 2 times of n square divided by n square minus 1 equals to 12. So here you see that this plus n and minus n are cancelled by each other, and we get 2 times of n square divided by n square minus 1 and its whole square minus 2 times of n square divided by n square minus 1, and this whole equals to 12. And now you see that we have 2 over n square minus 1 be the common term, which is lies here and here. And now we take this term equals to y. So if we take y equals to 2 times of n square divided by n square minus 1, so that this expression will becomes y square minus y and equals to 12. So here we move this 12 in the left hand side, and we get the quadratic equation in standard form is y square minus y minus 12 equals to 0. And now we easily make the factors of this equation. So here we need any two numbers whose product is minus 12 and whose sum is minus 1, and these numbers are minus 4 times of y and plus 3 times of y, and minus 12 equals to 0. So that here we take common y on the first terms and we get y minus 4, and here we take common plus 3 and we get y minus 4 equals to 0. And in the next step, you see here we have y minus 4 be the common expression. So we take it common y minus 4 and you get here y plus 3 equals to 0. And now we have two cases. So our first case is y minus 4 equals to 0, and the second case is we have y plus 3 equals to 0. So in the first case you get the value of y equals to 4, and in the second case you get the value of y equals to 3. And now we back substitute the value of y, and here you see that we take our y equals to 2n square over n square minus 1, so that we back substitute this value of y on both of these cases and we move towards our final destination. So that we have our y is 2 times of n square divided by n square minus 1 equals to 4, and in this case 2 times of n square divided by n square minus 1 equals to 3. So here we need to solve these two equations. So now first we rearrange these terms and we convert it into the uh, standard quadratic form. So here we move this n square minus 1 to the right hand side and we get 2 times of n square equals to 4 times of n square minus 1, and we have 2 times of n square equals to 4 times of n square minus 4, and we move this 2 times of n square to the right hand side and this minus 4 to the left hand side, and it will be equals to plus 4 equals 4 times of n square minus 2 times of n square, and this will becomes 4 equals to 2 times of n square, because when you subtract 4 minus 2 you get here 2, and in that case we have n square equals to 4 over 2, and we cancelled these terms, and this is 2 times of 2 is 4, and you get here n square equals to 2. And now we take the square root on both of the sides and you get n equals to plus minus square root of 2. So this is the first two real roots of the given equation. And now we focus on the second case, and our second case is here we have 2 times of n square over n square minus 1 equals 3. So now again we move this term in the right hand side and you get 2 times of n square equals to 3 times of n square minus 1. So now we multiply this 3 on both of the terms and you get 3 times of n squared minus 3, and here you have 2 times of n square equals to 3 times of n square. So now we again move this 2 times of n square in the right hand side and minus 3 in the left hand side, and we get 3 equals to 3 times of n square minus 2 times of n square, and here you get 3 equals to n square. So now we take the square root on both of the sides and you get n equals to plus minus square root of 3. So these are the other two roots of the given equation, and these are the four roots of the given equation, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.